In this video, I'll be solving a great circle sailing question, and the question is that we have to find the distance, the initial course, the final course, and the position of the vertex between the given positions. Position A is 49 degrees 50 minutes north and 5 degrees 50 minutes west, and position B is 32 degrees 29 minutes north and 64 degrees west. So we also have to additionally find out the longitude in which the great circle track crosses the latitude of 40 degrees north. Alright, so let's start with the question here. And to start the question, we first have to draw a sketch which roughly represents what we have in the question here. So we have position A and position B. So you can see that position A is north of position B, and position B is west of position A. So that is how you have to draw the diagram. So both the positions are in the north hemisphere, so you will draw it with respect to the north pole, which is P. Your ship is proceeding on a course like this. Alright, this is the ship's course. So A and B are drawn with respect to north pole, and the latitude of A and B, A is north of B, and longitude of B is west of longitude of A. So that's how you have to visualize it, and this is the first step, and this is where you have to spend the most time. Get the drawing correct before you start proceeding with the question. So make sure you check it a couple of times like I am, verify that this is correct, and only then proceed with the rest of the question. Once you verify that the drawing is correct, then of course you have to find out the sides of the triangle and any angle if you can. So the first thing we'll find out is PA. Now PA is equal to, as you can see, PA of the triangle is equal to 90 degrees minus 49 degrees 50 minutes, which is the latitude of A, which will give you 40 degrees 10 minutes. So PA is 40 degrees 10 minutes. Now why is that? Because A's latitude, if this is equator, 0 degrees equator, A's latitude, this is A's latitude, and this is 49 degrees and 50 minutes. Alright, that's why PA will be 90 minus 49 degrees 50 minutes, because from the north pole to the equator is 90 degrees. So this distance here is 90 degrees. Alright, so similarly PB would be 90 degrees minus the latitude of B, which is 32 degrees 29 minutes, and you get PB as 57 degrees 31 minutes. Finally, you calculate angle P in the triangle PAB, where P is the D long between the positions of A and B. So D long between the longitude of A and longitude of B. So because the value of longitude of B is higher and both are same names, when both the longitudes are same names, that is both of them are west, then D long will be the difference of the smaller number from the bigger number, which is 58 degrees 45 minutes. Right, and it will be west because we are going from A to B, so we are going westerly, so D long will be west in this case. Alright, so we found out the two sides and the included angle. So in that case we can use the cosine rule to calculate our great circle distance. So cosine rule is, for the cosine rule to be used, we need the two sides and the included angle between it. So we've got the two sides as PA and PB, and the angle included between it is angle P, so we can use the cosine rule. So if we have two sides and the included angle between it, we can use the cosine rule. So the first thing we'll do is find out the great circle distance. So to do that, we put it in the cosine formula, which is cos of P, which is the included angle, equals to the side opposite to cos P. So side opposite to angle P is AB. So we have cos AB minus the product of the cos of the other two sides, which are PA and PB, divided by the sine of the same two sides, PA and PB, in the denominator. Alright, so we write down cos P, which is the included angle, and then we write down cos AB, which is the side opposite to the included angle, minus the product of the two sides, and then divided by the sine of the two sides as well, PA and PB, the remaining two sides. Now we have to find AB, that is the great circle distance. So to do that, we have to take all the other values on one side and keep AB on one side, because AB is the unknown and we row the rest of the values, so they are the knowns. So what happens is, I'll take this one here, which will make this equation cos P times sin PA sin PB, which is equal to cos AB minus cos PA cos PB. So we got rid of the denominator, and then I'll take this here, so negative becomes positive, so cos AB will be equal to cos of P multiplied by sin of PA multiplied by sin of PB plus cos PA cos PB. Then it's a matter of just putting in the values. This is P, this is PA, this is PB, so just put in the values. You have the values already from above. Put in the values, get the values from the calculator. I have stuck to 5 decimal places. You can go more if you want to, but go at least up to 5 decimal places. That enhances the accuracy. See if your values matches mine. If they're not, then make sure you check it again. I'm hoping that my values are correct. And then you get cos AB equals 0.69266. So take cos to the other side, which will make it cos of inverse of the value, and you will get AB as 46.16 degrees in your calculator. Multiply this by 60 to get the great circle distance. So 2769.5 is the distance. So one part of the question is done. Now that you have AB, you can use the cosine rule to find out your initial cos, which is cos A, which, if you go back in the triangle, is this angle here. Alright, so you have to find this angle, then we can find out the course of the vessel. Alright, I'll show you how to do that. So we use the cosine rule. Put cos A equals to the cos of the side opposite to it minus the remaining two sides divided by the sine of the remaining two sides as well. Then just put in the values. I've shown this before, so I will not repeat myself. Just put in the values of PB, AB and PA wherever it is required. You have all the values now. AB you can use as 46.16 degrees, of course, because whenever you have to use a sine, cos or tan, make sure you put the value as degrees, not as miles. So you don't put 2769.5 miles. AB will be in degrees, which is 46.16 degrees, as you can see in my working out. Alright, then simply put in the values in the equation and match with mine. Again, I have stuck to 5 decimal places. What you get is cos of A equals 0.01666. Then take cos onto the other side, gives you a cos inverse of the same value, which you get as north 89 degrees west. Now don't worry about north and west at this stage. What you will get in your calculators is 89 degrees. Now when you get 89 degrees, go back to the drawing I showed you. Now this value is 89 degrees. Now when this value is less than 90 and your vessel is going in the westerly direction, when looking at it from the North Pole's perspective, then this quadrant becomes northwest. How? Well, let me show you how. So I'll show you next to this diagram itself. Okay, so say if this is north and this is west and this is south, right? Your vessel is proceeding in the westerly fashion, so it's going in the westerly direction. So this is how your vessel is going from A to B. Now how do you know whether it's going from here or not? So that is the thing you have to remember, that when the vessel is going in the westerly direction and you're looking at it from the North Pole's perspective, whenever the value is less than 90 degrees, the first quadrant is the northwest, this quadrant here. And whenever it will be more than 90 degrees, as you will see with the case of the final course, the quadrant will be southwest. So in this case, the initial course's value is 89 degrees, which is less than 90 degrees. So that means your vessel is still in the northwest quadrant. It is proceeding in the westerly direction, but it is still in the northwest quadrant. So that's how I have named my initial course north 89 degrees west. North 89 degrees west is somewhere here. This is also equal to 271 degrees true. So 89 degrees from 360. So 360 minus 89 will be 271 degrees. So that's your initial course. Then you have your final course, which is angle B. So before you find out your final course, you have to find out the internal angle B here. Alright, because you have to use the values of the triangle to first find out internal angle B, but that will not be your final cos. I'll show you what your final cos is. So again, for your final cos, cos of B equals cos of the side opposite to it minus the cos of the remaining two sides divided by the sine of the remaining two sides. So we use the cosine rule again. Then simply put in the values that you have from before, put them in the calculator, match with mine, check the values that I've got at every stage, and then what you get is cos of B equals 0.64458. Take cos on the other side, it gives you a cos inverse. So cos inverse of 0.64458 will give you 49.9 degrees, which, because to make it easy, I've rounded it off to 50 degrees. Now I don't know what has been taught to you in your college, go with that, but I like to round off the course values because course of 49.9 is not possible on ships. Okay, so try to round off the courses. Distances in decimals is fine, but courses in decimals is not a very practical way of looking at things. All right, so that's why I just round it off to the next possible whole number. So in this case 49.9 will be about 50 degrees. So my final course in this case, as you can see, my vessel has been proceeding in this direction here, right? So my final course is actually this angle here, measured from the North Pole. Just like my initial course I found was this, but actually my initial course was this angle here measured from the North Pole. That's why this course was 271 degrees, right? That's why my final course is also measured from the North Pole all the way to the vessel's course, because that's the direction which the vessel is going. The value that I found of 50 degrees is this value here is 50 degrees. But I have to find out the outer angle, this value. So how do I do that? 180 degrees minus 50 degrees will give me the outer angle value. So 180 degrees minus 50 degrees, which is your internal angle B, it gives you 130 degrees. 130 degrees is the outer angle here. When I say 130 is outer angle here, then again if I look at it from this perspective here, my vessel is going in the westerly direction. If 130 is the final course, that means now I am no longer in the northwest quadrant. I am actually now in the southwest quadrant. By how much? Well, this much is 90, and then 40 degrees more into the southwest quadrant. That means from south I am about 50 degrees to the west. So southwest, this is my course. Alright, so I'll show it to you again what I mean. If I erase all these things, so you can see my outer angle is 130 degrees, right? 130 degrees means this is 90, right? Then 40 degrees more. 90 plus 40 is 130. This is west, this is north, this is south. But we don't say west 40 degrees south. What we say is south 50 degrees west. Because if this is 40, the remaining is 50. So this is 180. If I go 50 degrees from south towards west, this will be 180 plus 50, which is 230. And that is why my final course is south 50 degrees west, which is equal to 230 degrees true. Alright, so just watch this again if you're not very sure. But what you have to do with the final course is always find out the internal angle B and then subtract it from 180 to find the outer angle B. Once you find out the outer angle B, figure out the quadrant in which you are in. If it was less than 90, it would have been in the northwest quadrant, in this case, when the vessel is proceeding west. If it is more than 90 degrees, like it was in this case, then I am in the southwest quadrant. Alright, so that's the whole idea behind it. Now, the rule for the vertex position is if initial and final courses are in the same quadrants, vertex lies outside A and B. If they are in the different quadrants, vertex lies between A and B. In this case, your initial course A was in the quadrant north and west, and the final course is in the quadrant southwest. So when they are in different quadrants, vertex will lie between A and B, always towards the higher latitude, which is A. So that's why I have put vertex between A and B towards the higher latitude. Now I've just put this roughly. I don't know exactly what the position is. We have to find out the position of the vertex. That's the fourth part of the question. To find out the position of the vertex is at 90 degrees. So what we can do is we can take this triangle here, or you can also take triangle PBV, depends on what you want to do. But I'll taking triangle PVA because V gives us a 90 degree. Then we can use the Napier's rules. Alright, we can use the Napier's rules. I have made videos on Napier's rules as well. I'm sure you can find it on my channel. Just find the video and watch Napier's rules. So in Napier's rules, in triangle PVA, we need one angle which is equal to 90 degrees, which is angle V is equal to 90 degrees. Then we put the side next to angle V, which is PV and AV. If you look at the diagram, the sides next to V is PV and AV. Then the angle opposite to AV is P, and we put 90 minus P. So whatever we put in the bottom semicircle, we always add a prefix of 90 minus to that. Angle opposite to PV is A, so we have 90 minus A, and then the remaining is 90 minus PA. So this is about Napier's rules. We draw a circle, we divide it into two semicircles. The top semicircle has two halves and the bottom semicircle is divided into three parts, and you can see how I have written it. So I have made a separate video on Napier's rules. I'm not going to waste too much time explaining the Napier's rules here. Make sure that you watch it on my channel. Alright, so the rule of Napier's rules is, firstly find out what do we have. So we have angle A because we know the initial cos. We also know PA because that was given to us at the very beginning. We found it out actually based on the latitude of A. And what we have to find out is PV to find the latitude of vertex, and we have to find angle P to find the longitude of vertex. So let's start with PV first. So we'll use the ones we know to find out the ones we don't know. Now because we know 90 minus A and 90 minus PA, and we have to find out PV, we have to put all three in this equation. So this becomes an equation, this forms a mushroom. So we always have to find a mushroom. This forms a mushroom. The rule is sine of PV in this case equals cos of the opposites, which is cos of 90 minus A, cos of 90 minus PA. Alright. So this cos of 90 minus A is also equal to sine of A, and cos of 90 minus P is also equal to sine of PA. So sine 90 minus any angle is equal to cos of that angle, and cos 90 minus any angle is equal to sine of that angle. So we put in the value of A as 89 and PA as 40 degrees 10 minutes. We get this value here, take sine to the other side, and we get PV as 40 degrees 9.6. Now PV is 40 degrees 9.6, that is 40 degrees 9.6, but that is not the latitude of the vertex. The latitude of vertex will be from the equator, if this is the equator. So to do so, we have to find the latitude of vertex. We'll subtract 90 degrees minus PV. PV is the distance from the pole to the vertex, but to find the latitude, we have to find it from the equator to the vertex, and that is 49 degrees 50.4 minutes north. It cannot be south because both the positions A and B are in the north hemisphere. The next we have to find out is 90 minus P to find the longitude of the vertex. So what I'll do is I'll erase all this, so to make it less cluttered. And again, you have to use the ones that you knew to find out the ones that you don't know. So now in this case, you know again 90 minus A, 90 minus PA. Don't use PV that you have found out, because PV is something that you just find out, and if there is an error in it, you will continue that error. So use 90 minus A and 90 minus PA to find P. Now to get all these three in the equation, what we have is something like this, right? We are using all these three. In this case, 90 minus PA becomes the middle, and 90 minus P and 90 minus A becomes adjacent to it. So the equation here for Napier's is sine 90 minus PA equals tan 90 minus P and tan 90 minus A. So whenever it's adjacent, it's tan. Whenever it's opposites, it's cos. So sine 90 minus PA is also equal to cos PA. And then we got tan 90 minus A down here, leaving tan 90 minus P on one side because that's the unknown. Put in the value of PA, 40 degrees 10 minutes. Put in the value of tan 90 minus A is 89 degrees, right? Then solve the equation. Check with my values what I have done. Alright, so this equation gives this. Then take tan to the other side, gives tan inverse. 90 minus P will be equal to 88 degree 41.5, and then P, which is the P in triangle PVA, gives a value of 001 degrees 18.5 minutes. This is the D long between the position of A and position of the vertex. Now you can see from the drawing itself that the vertex is further to the west of A, right? So if longitude of A is 5 degrees 15 minutes and vertex is further west to A, that means D long is west. and that means you will add the d long that you have just found out to find the longitude of the vertex. So position of the vertex in this space becomes 49 degrees 50.4 north and 006 degrees 33.5 minutes west. Lastly, we have to find out the intermediate point. The intermediate point given to us is 40 degrees north, which we are assuming will be somewhere here because the latitude of the vertex is about 49 degrees 50.4 minutes and latitude of A is also somewhere around that. So we are assuming that latitude of M 40 degrees will be somewhere here. So this is just an approximation. But what we'll do is we have to find the longitude of M. So we have been given the latitude M, we have to find the longitude of M. So to do that, we use the triangle PVM because this gives us a 90 degree of vertex angle. And then we can use the Napier's rules. So you have to get the vertex involved because the vertex gives us a 90 degree angle. So in triangle PMV, vertex is equal to 90 degrees. Write the sides next to the vertex, which is PV and VM, the angle opposite to PV and VM with a 90 minus prefix, and then the remaining side 90 minus PM in this bottom. We know is 90 minus PM because we know if we know latitude of M is equal to 40 degrees north, so PM will be 90 minus 40, which is equal to 50 degrees. Alright, that's why we know PM. And then we know PV, we have calculated PV before. All we have to do is find out P, because P will give us the D long between position M and position vertex. So I'm just calling it position M. You can call it anything you want. This is not an international notification, right? So what we know is we know two things and we have to find the middle. So in this case, sine 90 minus P becomes the middle part, and the adjacent values next to it becomes tan of PV, tan 90 minus PM. Sine 90 minus P is also equal to cos P. Put in the value of PV, put in the value of 90 minus PM here. This will give you cos P equals this value here. Make sure you check your calculator and verify the value as well, and that will give you D long between, this is between M and vertex, is equal to 44 degrees 55.2. Now I can see that the position of M is further west of the vertex. So as we are going from vertex to B, we are going further west. So D long or longitude of M will be further west of the vertex. That's why D long will be west. So if I know the longitude of vertex as 006 33.5 minutes west, I know the D long as 44 degrees 55.2 minutes west. I will add to this and I get out the longitude of M. This is the longitude of the intermediate point of 40 degrees north. Alright, you know where we got the PM from, you know where you got the PV. So PV is over here. If you have forgotten, you found out PV before. There you go. This is PV. Alright. So don't think that I have used any value that I have not shown you how to calculate. All the values have been calculated before. Alright, so I hope you understood how to solve this question. Let me know if you have any doubts about this great circle question. I'm happy to answer it. Alright guys, I'll see you soon with my next video. Keep studying hard, keep working hard, and let me know if you want me to make videos on any particular topic. Bye guys.